All right, so Unit 1, Worksheet 5, or Day 5. The notes is the worksheet. The worksheet is the notes. We'll just work through some of them together. All right, piecewise functions. After talking with other math teachers, I think it's correct that you guys did not do this last year. So I thought you had, and you guys acted like I was crazy last week, and you were correct. I was crazy. Piecewise functions. A definition, although this isn't a great definition, is it's a function defined in pieces. I feel like that definition would not fly in an English class, right? It feels rather circular. But this function has two pieces to it, so we call it a piecewise function. The main thing with piecewise functions, and this is what will, I think, keep you out of trouble, is that you use only one piece at a time. Use only one of the pieces at a time. And so for any problem, you might need to use all of the pieces through the course of a problem. But when I want to find, looking at number 1, f of negative 8, I am not going to plug negative 8 into both of those pieces. I'm only allowed to plug it into one. And the reason is, and this is what is maybe confusing about piecewise, is that it's sort of an if-then statement, but it's an out-of-order if-then statement. Because the if part, the condition is written second. If x is less than negative 4, then we use x plus 8. If x is greater than negative 4, then we use 1/2 x minus 4. So it feels a little bit out of order because normally we read left to right, but on this one we use the right-hand information first to figure out which of the pieces to use. Just so we can call them something, I'm going to call it piece A and piece B. I mean, you could say plug it into the top or the bottom. That's fine too, but just to give them a name. And then we're going to work these three together. Now, on the first one, like as usual, I'm going to overkill how much work I show, but it will demonstrate at least the thought process that you have to make. So you don't have to write all this stuff down, but there are a number of steps you got to take to figure this thing out. So f of negative 8. First of all, is that negative 8, is that an x value or a y value? That's an x value. So x equals negative 8. So now I want to figure out which condition it meets. Is negative 8 less than negative 4, or is negative 8 greater than negative 4? That's not hard, although the negative sometimes throws people off. Is it less than negative 4 or greater than negative 4? Less than. Negative 8 is less than or equal to negative 4, which means we're on branch A, which means we'll use the expression for branch A. Negative 8 plus 6 is negative 2. So that's, 5 steps or so? None of them really that hard. But if you try to do them all in your head, maybe something gets mixed up somewhere. Let's show a little bit less work for the next one. For negative 4, let's see. Let me just ask it straightforward. So which branch are we going to use? Branch A or branch B? A, because it's equal to. So I'm not going to write all that out. I'm just going to make a note to self that I'm using branch A. So negative 4 plus 6 is 2. The third one there, f of 10, which branch are we going to use for that one? That would be B, because 10 is greater than negative 4. So I'm not worried about branch A at all. I'm going to do half of 10 is 5. 5 minus 4 is 1. You can see I intentionally gradually showed fewer and fewer steps. Still got the right answer. Show as much work as you need to. I don't suspect anyone will show all the steps I showed on the first one. Many of you will just sort of jump to the answer, which is fine, but be careful because you are having to think through a number of things, easy things, but a number of things to get to that final answer.
Is that just how we leave our answer?
And that's just your answer. Okay. I would say be careful if it's a 3-part problem like that. Make sure I know which one is which. So if I didn't have that and then just out here to the side you had -2 and 2 and 1 written, I'd be like, well, how do I know which is which? So either label them or do it kind of like I did so it's clear which one goes with which.
Bless you.
All right, why don't you try number 2? So there's our answers to number 2. Hopefully you got all 3 of those. Let's jump down to number 6. Write the piecewise function. So this is a little bit different. You're going to write the function that goes with that picture. I guess the first question would be, how many pieces am I going to need? 3. And I'm going to label the pieces on the graph this time. Well, I'm going to label them several places. And so I know the ABC is not really part of the answer, and the if-then is not really part of the answer, but that helps me keep things straight and figure it out here. Let's, just like we looked at the if part first when we were plugging things in, let's handle the if part first when we're writing the equation. So if I'm looking at branch A, maybe I should label these. We'll go in order. Branch A, branch B, branch C. Again, that's not officially part of the answer, but you're welcome to write more information to help you get to the right answer. So the x values for branch A, oh, by the way, that's another way to think of this, is the if part is the x values, the then tells you the y values. So the x values go from -6 to -2. -6 to -2. X is between -6 and -2. But x is bigger than -6, or equal to, and x is less than, not equal to, -2. So some of the open circle, closed circle stuff going on there. What's the y value of branch A? -4. So this is going to be a relatively easy function because they're all constants. So it's not too bad. Why don't you see if you can figure out pieces B and C? So there's the rest of that function. Hopefully you got all those pieces right. All right, let's look at some graphs. Number 7. Again, we got part A and part B. I'm going to do a lot of color coding here, so you don't have to, but usually there's 1 or 2 people per class each year who will, even on their test, get their colored pencils out and color code everything, and that is completely okay. If it helps you keep straight who's what and where it goes, then by all means do that. So I'm going to put the part A in blue and part B in orange. You know, whatever color you choose doesn't really matter, but if that helps you keep it straight. And again, I'm going to label it. Maybe a little overkill, but maybe a helpful reminder that if x is less than 2, then I'll graph square root of x. If x is greater than 2, then I'll graph 5. So there's a pretty key value of x going on here at 2, because that's where it changes. So before I graph anything, I'm going to build a wall at x equals 2. Because that's where the change happens. So x equal 2, I'm building a wall because If x is less than 2, I'm going to graph y equals the absolute value of x. And when x is greater than 2, I'm going to graph y equals 5. None of any of that is my final answer yet, but I'm thinking through, I'm getting prepared, I'm staying organized on what goes where. So x is less than 2, that's on this side. I'll graph absolute value of x. A little side note, you gotta know how to graph the parent functions before you start worrying about where they go. Maybe it's helpful to do a quick sketch to the side. I know what absolute value looks like. So I'm going to graph that, but only when x is less than 2. So start at 0, go up to 1, 1. I'm headed toward 2, 2, but that's the wall. When I reach the wall, maybe that's not even the best way to say that. What open circle or closed circle when I get to the wall? Open, because I can't get to 2. I can go all the way up to 2, but I can't quite get there. So you go right up to it, but you can't reach it. Like functions act like some teenagers when they're given instructions from parents, right? If here's the line, you go right up to the edge of it. I hope you don't do that with your parents, but the functions act that way. Go as close to the line as they can get, but don't cross the line. The other side I'm not worried about, I can send that off forever. All right, how about y equals 5? What's that look like?
Isn't it just a line?
It is a line. What kind of line? Can you be more specific?
It's just
Is it one of these lines or one of these lines?
vertical. Or horizontal.
Horizontal. So it's just a horizontal line at y equals 5. So 1, 2, 3, 4, 5. Again, I'm careful about the wall. What's going to be going on at the wall for this one? A closed circle, because like neighborhood B owns the wall. He can go sit on the wall and be fine. Questions on that? So, you've got to understand what goes where, but then you also have to be able to graph, like just regular old graphing. Why don't you try number 8? And again, use as much color and hints and extra stuff as you need. Part A, part B. We want to get you a little bit started. Where are we going to build the wall on number 8? 0. So I'm going to put a wall there at 0. All right, so see if you can take it from there, and then we'll come back and look at it. So there's the answer to number 8. Hopefully your picture looks like that. We graphed y equals 4 on the left, y equals square root of x on the right. Number 9 we'll kind of work through together because that's a little different because there's 3 neighborhoods. So I need 2 walls to separate people into their right neighborhood. Be careful how you talk about this. Can sound kind of unkind. So 2 neighborhoods. Region A, I'll graph y equals x squared. Region B, I'm going to graph -5. And region C, x plus 2. All right, slow down, come back with me here because something strange happens on number 9, especially region 2, that people will sometimes mess up. All right, y equals x squared. I remember what that looks like. That's the parabola, that's the u thing. Except that I'm only allowed to graph it on the left. So 0, 0, and I can own the wall there. Region A owns the wall, so I can put my dot on the wall. And then 1, 1, and 2, 2, 4, and 3 9s off the graph up there. So there's my half a parabola, because I'm not allowed to graph it on the other sections, the other neighborhoods. They have different people in them. Different functions live in the other neighborhoods. Y equals x squared only lives left of 0. Between 0 and 3, we have an easy function to graph. Y equals -5. So 1, 2, 3, 4, 5. I do need to be careful about the edges, though, about who owns the wall here. So on the left side, at 0, are we going open circle or closed circle for graph B? Open, because we're not equal to. So graph B's got an open circle on the left. What about the right half? Closed. He owns that right-hand wall there. Okay, and then lastly, I want to graph y equals x plus 2, but I'm only allowed to graph it when x is bigger than 3. Here's where we run into trouble, because how do you normally graph a line? So forget this piecewise stuff. If I ask you to graph y equals x plus 2, what would you do first? The plus 2, because b equals 2 or y-intercept is 2. So you would go up to 2 on the x-axis, or excuse me, on the y-axis, because it's the y-intercept. I switched to pencil because I am now in the wrong neighborhood. So I'm going to graph it because that's how I graph a line, but I'm going in pencil because I need to get out of that neighborhood as quickly as possible. Yes, I need to deport that function back into his correct neighborhood. But this is how I graph, so I've got to start there. What would you do next if after you put the first plus 2 on there? How would you graph a line? So forget the neighborhood thing. Just what would you use next when graphing this line? Where would you go next? Up what? Up 1 over 1, because the slope is 1. So I'm going to go up 1 over 1. I'm still in the wrong neighborhood, but this is how I graph a line. So I'm doing the best I can here. Up 1 over 1, up 1 over 1. Then when I hit the line, or hit the wall, he's open circle. Then I'll just keep going. My graph isn't done, though, until I get that function out of the wrong neighborhood. Right? Like if I just need to erase it. Okay, that didn't happen. Nobody saw that. Hopefully we don't get caught. Perhaps you've been to the wrong neighborhood when you had driving restrictions. Well, you can't leave Kingwood or whatever. And if you ever did, you probably didn't stay long, and you hoped that you could erase your tracks once you're back in the right neighborhood. Of course, with all the phone tracking stuff, that's tricky now. Hope they don't check it while you... Yeah, then that's exactly it. You hope I don't check your work while you're in the wrong neighborhood, because then you'd be wrong. You'd be wrong. But I won't check the work while you still have it, so clean it up, go from there. Number 10 is wrong on the key, so apologies for that. And I can tell you why it's wrong on the key. I was trying to make the key quickly, and instead of taking the time to build the wall where it needs to go, I did not build the wall, and then I missed the problem. So I did not mean to make an example out of myself, but I did. Build the wall first. That helps you keep track of who goes where. Again, when I tried to do it quickly without building the wall, I put the wall in the wrong spot, or didn't have a wall at all maybe, and it didn't work for me. So put the wall on there, then you can take off from there. All right, 11, 12, and 13, those are not piecewise functions. So it says write the equation. I'm not expecting, I don't need a piecewise. That's just review of parent function stuff. So people, if I don't say that, they start thinking, how do I make that a piecewise? Don't. Do it easier than that. All right, so there's sort of three things going on at the same time today, and you figure out how you want to do this. First of all, the assignment is worksheet 5, so maybe you want to work on that. Worksheet 1 through 4 are due on Friday, but I will happily take them today. You can turn them in up here if you're finished. And then lastly, the Schoology quiz is still hanging out there. It's not due till Friday at midnight, but we still have plenty of time, and there's hard copies up here. So there's like 3 things you could be working on. You have time to do all 3. So however you want to do it, go forth, use your time wisely.